Well, good evening, everybody. Welcome to Space Oddities. We'd like to wish you all a very happy Halloween. Thank you for being with us instead of out enjoying yourselves at Halloween. Perhaps you'll do that later. Whatever you're doing this evening later, we hope you have a fantastic time. And we're just glad you're with us. So thank you for being here. I'm joined this evening by the usual rabble, starting on my right with Daz. How are you, Daz?
I'm lovely, thank you. Getting a bit cooler here at the moment, but you what, mate?
No, nothing. Carry on.
Okay then. All right. It's only borrowed, mate. It's only borrowed. Now it's getting a bit cooler here now, and we're just expecting a storm to come in. So
yeah, I heard.
Not much in the way of seeing, I'm afraid. So
no, we've got a fairly cloudy night here, very hazy. We've got a hazy Jupiter I was looking at on the way home. But it can't be that cold because you haven't got your Arctic onesie on again this week. So
no, it's only next door if I need it.
Oh, that's all right then. That's all right.
Yeah, skin a polar bear and wrap myself up in
it. I'd like to say good evening to Roger. How are you, Roger?
I'm fine, thank you.
Good, jolly good.
All the better for being here with you.
For goodness sake. And Michael, how are you?
I'm well, thank you.
Right, Michael has been suffering some computer problems in the last half hour.
I think it's okay at the moment. So,
right.
if I disappear, you'll know why.
Right. Well, it's Halloween, so anything's possible.
Exactly. Yes.
Yeah.
It must be Halloween. It must be a Halloween bug.
Sorry.
Must be a Halloween bug.
Yeah, that's well.
Gremlins, it's gremlins.
There was actually a Halloween bug years ago that was set to go off on Halloween. Anyway. Joining us from the United States of America, we have Mr. Lou Mayo. How are you, Lou?
Oh, just thrilled to be in the U.S. Yes, and
was that a backhander?
I get to celebrate my favorite astronomical holiday, Halloween, or Samhain, if you were living thousands of years ago, and scare people.
Now that's. Oh, yeah. You see, he's disappeared.
He's gone.
It's magic. And Lou joins us this evening as everybody's favorite granddad. And
yeah, that's the best part.
Yeah. And he's got to run later. He's appearing in Chitty Chitty Bang Bang at his left.
Yeah.
So, I was going for 007 with this. Okay.
Bit of a Clive Dunn going on there, isn't there?
So where's the vodka martini?
Yeah.
Shaking that, Steve.
And we're welcome back after a long break. We welcome back Rachel. And we're very glad to have you back, Rachel.
Thank you for letting me come back.
To be quite honest, the gallery hasn't really been the same since.
What?
Someone's
been hogging it, Rachel. Someone's been hogging it.
Yeah. It's just, It's,
you mean Roger's gallery and some others?
Roger's portfolio.
Yeah. But no, obviously we'd like to thank Roger for stepping in and doing the gallery in your absence. For those of you that don't know Rachel, apparently everybody does really, but there might be somebody who doesn't know Rachel. And Rachel has been away on basically maternity leave, looking after her beautiful new son, Isaac. So we're very glad to have you joining us back here on Space Oddities tonight.
And
Rachel.
Johnny, don't forget Johnny. She's been looking after Johnny.
Oh, she's looking after Johnny as well.
Yes. Both the men in my life.
Yeah, I'm surprised you find time to be here at all with that going on. So there we are. So welcome back, Rachel, and we will be joining you very shortly. So that's us for tonight. As you know, our cast list, as it were, comes and goes week by week, but that's who you're stuck with tonight, viewers. And I'm sorry about that. Anyway, big thanks to all of you who've been buying us coffees. We are very, very grateful for the support. If you would like to buy us a coffee, we'll be putting the QR code up in a little while for you to scan. And, if you can buy us a coffee, it doesn't cost very much. And everything goes towards keeping Space Oddities going. And you can support us in other ways as well. Full details are in the comments of this video. So this evening, we've got Daz, who's going to be talking about what he started last week, which was solar storms. and is moving on to the Carrington event, I believe. Daz, is this correct?
Well, this week it was supposed to be a two-parter, but I think it's going to be a three-parter.
Right.
I'm
Well,
just
there's nothing wrong in that.
talk about this week the phenomena that happened on the sun to actually give us our solar storms. Then we'll
Right.
Carrington stuff next week.
So we'll be telling you all about solar storms and exactly what causes them. We've got the usual features. I'll be bringing you the week's news later. And of course, we've got the viewers gallery. Thanks to all of you who've sent in your images to the viewers gallery this week. I think it's quite a big gallery this week, isn't it, Rachel?
Yeah, it's quite a big one this week.
Good. So thank you all for sending your images in. As I say every week, we do enjoy looking at them very much. So keep them coming. Any astronomical photos, whether it's galaxies or nebulae or even just a skyscape, send them in to us.
I mean, we say big. 28 of them are from Roger. So.
Oh, 28. Yeah, that's big. Yes.
Oh, you've cut them down then.
I know. I have to cut them out, sorry.
Yeah, she took out the ones of your Veruca.
It's the Roger Hyman show.
So I'll just address my comments to Roger. Roger, if you would like to send in your gallery images to Space Oddities, then
I did.
Yes. And I'll just remind you of the email address, which is spaceodditieslive@gmail.com. If you'd like to send us an image, send it to spaceodditieslive@gmail.com. One image per email, please, because that makes it a lot easier to sort out. And if you could put something like gallery image or anything with the word gallery in the title of your email, the subject of your email, that would be much appreciated. So coming up next week, I'm off to Ireland this week because I'm giving a lecture at the County Mayo Dark Sky Festival. I'm off there on Thursday. My lecture's on Saturday afternoon. If anybody's attending that, I shall look forward to meeting you. Looking at the weather forecast today, it seems like the Dark Sky Festival is going to be rained out all weekend. And I'm going to go from a balmy 22 degrees here in Catalonia to 8 degrees in Dublin when I arrive. Exactly. So that will be a shock to the system. So I've got to actually pack some winter weather gear because I found it's going to be freezing and rainy.
You can borrow my polar bear skin.
Oh, that would be great. Yeah, just make sure the polar bear is actually dead this time, please, after that last debacle. So I shall be bringing you a report from the Mayo Dark Sky Festival next week. And I'm sure all we're going to see is rain. But anyway, there are lots of events going on because the event happens in 3 towns in County Mayo. And lots of events for the public to take part in, and lots of activities. So I will do my best to compile a report, and I'll give you that next week. It's always well supported as the Dark Sky Festival, so let's hope it is again this year, weather notwithstanding.
What are the dates again, Andy?
It starts on Friday evening and it closes on Sunday evening. So that's the 3rd, 4th of November. Yeah. So I shall look forward to being there. Anyway, we will get on with the show after all that. And
just a quick one. Steve is asking, is County Mayo one of Lou's relatives? Posh relatives. One of posh relatives. Yeah.
Yes.
We're getting lots of Halloween wishes. But then Gerard is evening from spooky Wirral. I think that's supposed to be the Wirral.
Wirral, yes.
Yes. Yes, County Mayo is indeed one of Lou's posh relatives. You can tell by the way Lou's dressed that he has some rich connections there. So,
Once a year, yes.
Yeah. So there we are. Anyway, well, because Rachel needs to get little Isaac out of the bath and into bed, he's been in there for 3 hours, so I think the water's probably a bit
all
cold
wrinkly,
now. So
all wrinkly.
You ought to go and get him out the bath,
One
Rachel. So
baby. Yeah.
we'll let you go first with the gallery, and please nobody phone social services because, well, they have Rachel on speed dial. So if you could just bear with us, where Rachel is now going to present this week's gallery, and again, we thank you very much for your images. So, Rachel.
Roger.
Oh, look at Roger. He's gone all quiet. I want to do that. So here we go.
No, well, thank you, Roger. It's been a big help knowing that it's been in your trusty hands. So thank you. Okay, we're starting off with the Ring Nebula, a nice little number by Roberta, and yeah, needs no other introduction really.
That's great, isn't
lovely.
it?
Mm.
That's really good.
This one's in Lyra, isn't it?
Yes.
Yeah.
It is.
So,
And people who see it for the first time in a sort of an amateur telescope are always quite amazed at how small it is.
yeah.
Because you see all the photos from the big observatories, it looks massive, but it is actually very small, as you can see here in a telescope. But well done to capture the Ring Nebula. That's lovely.
Yeah, really
Thank you for
lovely.
that.
Thank you, Roberta. And he sent in another one that he's done of the Orion Nebula.
Oh, wow.
Oh, that's
42.
lovely.
That's fantastic.
Gorgeous.
Mm.
Yeah.
Well done.
Yeah.
Really
What
nice. We'll be
camera
doing
is
that one
this?
soon when Orion's up earlier for us.
Yeah, you can almost separate the trapezium in there, the 4 stars.
right.
can't
You can, yeah.
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 Yeah, that's
Did
brilliant.
he say what he used to make that image?
I don't. Well, he just sent
Oh, yes.
that information,
Okay.
so
Okay. Got it.
not this time. Maybe he can tell us a bit more information if he's watching. Then we've got
look at that.
a lovely close-up of Milot 15, obviously, which is in the Heart Nebula, by Andy Weller, which is
Very
just
nice.
That's stunning.
Stunning.
Beautiful. That looks really
Lovely.
3D, doesn't it?
Mm.
Oh yeah.
yeah. You feel a texture by looking at it. I know that sounds silly, but
Looks like a couple of Viking boats coming out of the mist, doesn't it?
Yeah.
Into the,
I can see the front of the ships. Yeah.
yeah.
Yeah, that's beautiful. That's
really
well
good.
done, Andy. That's brilliant.
Then we've got a couple of moons, I think, by Sonia, which she's been taking obviously with her Google Pixel phone on her 10-inch Dob.
I like that one.
And
Yeah,
I
that's
believe
quite clear.
these are in order. So I think she took this one night, and then the next night she took the following image. So
Oh, Sonia, that is really good.
Very, very, very good.
There you go.
Very
Roger,
clear
got
for the
confidence
Google.
there, mate. That's lovely. Well done,
Yeah,
Sonia.
excellent. That is.
yeah,
Mm.
and then again, I think then she must have gone out the next night.
Yeah.
Said it was a bit more hazy then, but
Oh,
managed to
you don't
capture the
notice too
next
much,
phase.
do you?
Contrast.
Yeah, it
That's
just
fantastic.
improves it. Yeah, the contrast, as Lou just
Yeah.
said. It just
Yeah.
that's lovely.
Yeah. So well done, Sonia.
Very good.
And we've got M33, the Triangular Galaxy by Jerry. And I
Hello.
know Jerry does normally watch, so hello, Jerry, if you are watching tonight.
Wow.
It's just beautiful.
Very,
Oh, that is
very
lovely.
nice. Very nice.
It's like a sparkler
It is.
Mm.
It
or a
is.
Catherine
Like a
wheel, I
Catherine wheel.
suppose. Yeah.
Yeah.
You can definitely see the outer lanes really well, and the inner as it curls in. It's
Yeah.
brilliant.
And he's using ASI Air Pro.
Mm.
So I'm anxious to get mine up and running.
Yes.
Need to talk to Jerry. He's your man.
Okay.
Yes.
Then we've got Kev, who sent in the elephant's trunk, which I know
Ah.
he's done recently. He says there's a total integration of 2 hours. It would have been 4, but someone forgot to switch on the guiding for the first 2 hours.
I wonder who that would be.
Oh dear.
What could have
Wow.
been? What could have
Roger, are you
lovely,
sabotaging
though.
these people's pictures? You're going around.
Too right.
I think Roger's sending
right.
right. out. He's
It's not
hacking
cricket.
people.
Yeah.
That's really good.
That's
It's
lovely.
That's
really nice.
lovely.
Yeah.
Mm,
Very nice.
very good.
Then we've got old Trusty Lee, who's done a composite of the Milky Way, taking over a beach in Cornwall.
Sorry, did you
Right.
say Rusty Lee?
The Rusty Lee.
Trusty Lee without the
Oh,
T.
Trusty Lee, right, sorry.
So obviously he's done a shot for the exposure and then a shot for the
Oh, that's
sky. So he
beautiful.
said, not sure how it looks on devices because it's processed to be printed and it looks better on the laptop. Well, it still looks good to me, Lee.
Yeah.
So
Yeah.
That's all right.
And that horizon proves that the Earth is flat.
Oh
Yeah.
yes.
Definitely.
You know the flat earthers have got members all over the world. All over the
Around
globe.
the world, yeah. Around the
Around
world.
the world.
I mean, all these pictures are taken sort of in the last week. I think Yorkshire's been in a permanent state of storm for the
Yeah.
last
Yeah.
month.
Oh,
Ah, now
oh,
the
look
eclipse.
at this.
Oh,
Then-
Michael.
This
Yes,
riffraff
it
got in somehow. So, Michael, do you want to talk through your image?
Yeah, this is mine. I've got this Lumix bridge camera, which has got an equivalent of the 1200mm lens, equivalent to 35mm. And I've managed to get this through a gap in the clouds. It was cloudy most of the night, really. So I was lucky. I looked out and I saw the moon and got the equipment out. It was just on a tripod, 2/50th of a second, just the one shot, and that's what I got.
Is
So,
that the
yeah.
partial eclipse, Michael, or is that
It
your
is the
thumb?
partial.
Yes.
It is the
Or is
partial
it your
eclipse.
thumb?
It's not my thumb, but in front of the lens now. And I did remember to take the lens cap off. Yes.
Again, it was clear though. And what was the
Yeah.
partial eclipse? Was it between 8:30 and 9:30 or something? And
Yeah,
here
that's something
it
about
was,
that.
Yeah,
it was
round about
clear
then.
until 8 o'clock, until 10 o'clock it rained.
Oh, great.
So,
Yeah.
then again, we've got another partial eclipse moon by Lee.
Oh, that's
So
nice.
just a quick one before the rain descended. But again, I think it's still
That's
a really
great.
a lovely image.
Oh, that is
Yes.
lovely. That's worth framing. That one. That's just
Yeah, it's a nice one. That is.
beautiful.
Very good.
Not
Well
giving
done.
yourself enough credit, Lee.
Just missed the creator Tycho. I see.
Yeah. Amazing what you can do putting your finger in front of the lens, isn't it?
Mhm.
And we don't know who this is.
I'm joking.
It's another eclipse moon
Hey.
by someone familiar. Roger, go
Yeah,
on.
well,
You know
this-
you're
this-
desperate.
Yeah, well, this was an hour before, and this was just before it clouded over completely. And then about an hour or so after the eclipse maximum, it cleared again. So I
isn't that
had
always the way?
2 hours of awful weather.
Yeah.
But this is the best I could do.
That's very nice.
Very nice.
That's very good.
Mm.
Lovely, Roger.
Very
Thank you.
good. Then we've got another image by Roger,
Oh, nice.
which is Jupiter with Europa and Ganymede. Do you want to say which is which, Roger?
Well, Jupiter's the one in the middle,
Are you sure?
and Io is on the left and Ganymede on the right.
Right.
Yes.
Now, this
Yeah,
was
you
just done with my 5-inch refractor and a ×4 power mate, just to see how it was comparing with my other scopes. I mean, it's not bad.
Is it my eyes, or is there a tiny bit of surface detail on Io there? It's me, isn't it? It's me.
On Io.
Yes, it's you.
It's me.
Looks
Okay.
to-
It
I
looks
think-
yellow. It looks yellow.
Definitely
doesn't it?
yellow. It's definitely
Yeah,
yellow.
Yeah.
definitely yellow.
Yellow.
Yeah.
Yeah.
Mm.
So thank you, Roger.
Anyway.
On the surface.
And again, finishing off with Roger. You can talk through this one. Go on.
So same setup. I was just trying to get some close-up details as the moon looked rather steady that night, and just trying to see how good I could resolve.
Well, I think you
It's quite
succeeded.
quite a good amount of detail from Schroeder's Valley there. It's probably
right.
about the best I've managed to get of it, actually.
Yeah.
So
Mm.
There's some
Nice.
nice colour in
And,
there.
Yeah,
as well.
really nice.
Yeah.
colour.
Yeah.
Colours are amazing.
and also the details behind the Bay of Rainbows, Sinisiridium. There's a
Mm.
lot of details around there as well. So I'm very pleased with it.
Oh, it
Very
should be.
nice.
Yes.
Lovely.
And I chose Rogers to finish on this week. So a real mix,
Okay.
a lovely mix of moons and planets and Milky Ways and all sorts. So thank you, everyone.
Fantastic. Thank you all
Excellent.
very much for those lovely images. Absolutely superb as always. We're always completely in awe of your photographic and astronomical skills. So there we are. Okay. Moving on to Roger, who's going to tell us about hopefully tell us about the night sky. What's going on in the night sky at the moment, Roger?
Storms and wind and rain. It's not looking good at all. But here we go. Anyway, so here we are for from Halloween to the 6th of November. All right. Okay.
Where's Lou's Whippet?
Anyway,
funny.
moving on.
Moving on. Sorry.
The we've got the waning gibbous moon to eventually the last quarter over on Sunday night. Well, early hours of Saturday actually, but we won't pick either here or there. And here we go. And this is what this. So this was what it was an hour before. You could just about see the very sliver of the eclipse there, but we'll move on because we've already seen that. Now this was done last night, and this is taken 12 hours apart. So you can see the amount of difference on the terminator between the nighttime shot and the morning shot.
Right, that's true.
Yeah.
Yeah, because you can see how it's eaten into Mare Crisium there to show how much the just 12 hours is made to it. But, yeah. Okay, moving on. So, oh dear. It's another Rogers gallery.
Oh,
so I was just showing the definition of the scope that I've got to bring out some of the details of Mare Crisium and some of the other craters on the Terminator there, and it's coming out quite well, I think.
The resolution is amazing, Roger.
Isn't it? Actually, thinking that.
And it was very high humidity in the 90s, unfortunately. So there was a lot of wibble wobble on the atmospheric conditions there, but obviously
the detail around Mare Crisium there was brilliant.
Yeah,
and it'll be even better when I get steadier conditions, it'll be even better.
Right.
So anyway,
what is that feature? Oh, sorry.
Carry on.
What is that ridge that looks like a ridge going down the right-hand side of Mare Crisium there?
Oh yes.
Do you see what I mean?
Sure. Yeah, I know what you mean. It's just I don't know the actual. I don't know if there is an actual name applied to that area there.
Oh, that's interesting.
Yeah.
Lovely. I mean, that definition is amazing, Roger. Yeah.
Okay. So we've got to 10 o'clock on the week through here because we've got the clocks back. So extra hour of so-called viewing, providing the sky's blooming well clear. And as you can see, Orion is almost clear of the horizon now. So things are looking more favourable for observing those lovely objects in that constellation. We've got Saturn, which is now heading down towards the southwest, but Jupiter is dominating the higher skies, and almost overhead we've got the Andromeda Galaxy. So all's well and good. But the only thing is the unfavourable large percentage of moon, which is still illuminating the night sky. Unless you've got some broadband filters. But it does move out the way through the week, so that's not all bad. So there we go. And in the morning, this is from 5 o'clock, we've got the brilliant morning star of Venus. And that's worth a look at. But if you're interested in other objects entering into our solar system, we've got a comet, and that comet is coming through Ursa Major at the moment, and that is comet 2023 H2 Lemon, and that was only discovered in April this year.
All right,
and it's quite bright.
I've got this mapped out for a week, and you can see how it is moving through the constellations from Ursa Major through Bootes and then on through into Hercules. But it is moving at quite a pace. So it was at perihelion 2 days ago, and it will be at perigee on the 10th of November.
Blimey.
And it'll only be 0.19 of an astronomical unit from the Earth at that point. So it's going to be quite interesting.
Do you know what its apparent magnitude is predicted to be?
I've got the information on the left, Lou. So
there you go. Sorry about that.
That's all right. Tonight it's 6.9. It does go down to about just under 6, and then it starts to rapidly fade as it streaks away out of the solar system.
Have you tried to image it, Roger, or has it been too cloudy?
Unfortunately, I've got my house in the way because at this point, Ursa Major is quite low to the horizon, and unfortunately, I haven't got enough clearance to be able to see it. But
so I should be able to see it from here.
I guess so.
Yeah, because Ursa Major's a lot higher.
Yeah, I mean, if you've got a good northerly horizon, then all well and good, and carry on.
I'm gonna try.
I've not seen any actual images of the comet yet, but no doubt there will be due to its brightness. But it's certainly herring along quite at a rapid pace at the moment.
Yeah, absolutely, it is.
Yeah, so it would be quite a good time lapse, even just for a few hours. I would have thought on one night.
Yeah.
Okay, so James Webb has produced some amazing images as it usually does, and this one is the Crab Nebula. Ta-da!
Oh, that's lovely.
Oh wow, that is
absolutely amazing,
stunning, and you can actually now. Have I got this correct? Right at the center, you begin to see the structure around the pulsar. Do you see the sort of the ripples?
Yeah.
Right in the center?
Yeah.
Which come out very clearly in X-ray, of course. But that looks to me, unless my eyes are deceiving me, you've definitely got sort of circular ripples there, haven't you?
There is.
Yeah.
Almost like gravitational lensing.
Yeah, that's
right.
That's right. Yeah, how strange.
Yeah, so
I've never seen that in the infrared before. I shall have to investigate that, see what that's all about.
I mean, what I like about this Crab Nebula is you can go online and you can see time lapse of it actually expanding from about the 60s.
Yeah, I've seen that.
Surprising how much is actually as expanded.
Right.
It's amazing.
Really spectacular.
Yeah. It's a hell of a size as well. If you look at that, 2 light years. 1 arc minute. My goodness me.
Right. So the next slide is a comparison between the Hubble and the James Webb. And here we are.
Cool.
Oh.
Yeah, you see the detail that the Hubble didn't get.
Yeah, considerable difference completely.
Yeah, absolutely. It's a completely different nebula, isn't it? It's amazing.
Now the Hubble image is a visual image. The James Webb image is an IR image, so it's colored. Somebody took a crayon to it.
Yeah.
So you have to look for structural differences instead of color, and they almost look like different nebula.
Yeah, exactly. Yeah.
Yes, they do.
They do. Yeah.
But they are identical in size and position. So
yeah. Claire says, "Hi, Claire. By the way, she says she likes the first version. I think they're both beautiful.
Yeah.
But telling a different story. So yeah, she says it looks like a flower's drawn in the middle of it.
All right. Yeah.
Yeah. You're absolutely right, Claire.
Yeah.
Absolutely. Yeah. Yeah. Thanks. Okay. Right. So
we're going to go on to the Halloween theme images now.
Oh.
It's like an X-ray of a hand there.
Skeletal hand, yeah.
It is, isn't it?
Ooh.
Very much.
Yeah. And then we've got this one of Jupiter.
Oh yes. Oh. That is really scary.
It's like someone pressed his nose up against the glass.
Yeah.
Yeah. This sort of reminds me of a King Crimson album cover.
Yeah, it does. I was about to say exactly the same thing. It's definitely King Crimson.
Showing our age, aren't we?
Yeah, we are. We are. I mean, he looks like me after a night out, to be quite honest.
Yeah, and his face is melting.
Yeah, my face is melting. That was taken obviously by Juno, which is orbiting Jupiter, and it's completed its primary mission. It's now visiting the moons. We saw last week of its new image of Io, which was absolutely stunning. If you were with us last week, viewers, but yeah, an amazing image from Juno for Halloween. Fantastic.
Yeah.
Okay, that's for me done for this evening. Well,
Okay. Thank you very much, Roger. That's brilliant. Absolutely brilliant. So there we are. Okay, well, moving on. Just before we go any further, we'd like to show you how you can support us. So if you'd like to buy us a coffee to help keep Space Oddities going, then you can scan this QR code here, and you will find a link to it now in the chat if you haven't got a QR scanner handy. And also, we'd like to obviously thank again the people that buy us coffees, especially those that do so on a regular basis, and it helps us keep the ship afloat. So thank you very much for that. We'd also like to remind you that you can buy your very own Space Oddities T-shirts, and they are available for the ridiculously low sum of £19, including postage and packing in the UK. Please add £10 for foreign orders. And we know it's not exactly T-shirt weather at the moment, but, as I was saying last week, when you're all gathered around the winter, Roger's still wearing his. It's always sunny in Sparkford, obviously. When you're all gathered around the family home fire at Christmas and it gets a bit warm in that room with all the log burning, then, a T-shirt is the most comfortable thing you could possibly slip into, probably. So £19. A mere snip at £19. But for the winter, we have a special Space Oddities hoodie. And these come in two types, the pullover type and the zipper type. The zipper type has the design on the back. The pullover type, conversely, has the design on the front. And these, again, are made of really warm, good quality material for the winter, £35, including UK postage and packing. Please add £10 for foreign orders. So there we are. And again, full details are in the description of this video. Let's move on. I'm going to tell you the news now. So I'm going to don my Reginald Bosanquet hat now and tell you what's been going on. It's been a busy week for news, and unfortunately, I haven't had time to put all the stories in that I wanted to. But we've got a good few to keep everybody occupied tonight. So here is the news. So let me just organize myself here, and we start with news that there are some hidden structures beneath the moon's far side which have been discovered recently. And specifically, these have been discovered by the Chinese Chang'e 4 lander. And it's discovered a couple of things. It's discovered a buried impact crater that nobody knew was there. But more interestingly, perhaps, Chang'e 4 has found 5 distinct layers of ancient lava going back billions of years, covering a large area on the far side of the moon. And the interesting thing about these is that as the layers get near the surface, they get progressively thinner. So when the moon was cooling, the volcanism in the moon or the internal activity was beginning to run out of steam. So every time it sort of belched a layer of lava towards the surface, it was less powerful. So the layers are thinner. And this had never been seen before. And Chinese scientists say that they're not convinced that the moon is geologically dead. There may be deep reservoirs of magma still inside the moon, which would be something very, very interesting indeed. And Chang'e 4, of course, was the first spacecraft to land on the far side of the moon. For which, of course, the Chinese are to be congratulated, because it's hard enough to land on the near side of the moon, as the Russians found out recently. So they did an amazing job landing Chang'e 4 on the far side of the moon, and now has discovered these hitherto unsuspected lava layers that do go back billions of years. So that's quite interesting. Got a few moon stories for you tonight. The next one is that a company called Icon have got a plan to 3D print houses on the moon for when there's a permanent settlement, because obviously the astronauts are going to need to live somewhere. And they've developed this 3D printer that you can see an artist's conception of here. The unusual thing about this is that they plan to build the houses out of the lunar soil, the lunar regolith, 3D printing it directly from the lunar soil. Now, this is quite interesting because lunar soil is incredibly nasty stuff. It's made up of particles that are very sharp, it's very toxic, and the Apollo astronauts had a really hard time with lunar dust when they were on the moon because it sticks to everything. And their way of thinking is, well, why not use that to get rid of it to actually 3D print houses? And they're doing the first tests with this 3D printer in a vacuum chamber at NASA's Marshall Space Flight Center in February. And the printer is going to attempt to construct houses out of obviously a simulated lunar regolith. And they're going to try it with lots of different types of simulated lunar regolith, lots of different types of simulated moon soil, and just to see what happens. So that's quite interesting. They plan to get this working on the moon's surface by the year 2040, if Project Artemis from NASA does manage to stick to its deadlines and get people living and working on the moon as they are meant to, as per the timeline. Doesn't seem very likely at the moment because Artemis is not, shall we say, progressing that well. All sorts of delays with the project, but presuming that that we will have humans living and working on the moon in a few years, they will be able to hopefully live in Icon's 3D printed houses. So that's quite an interesting story.
And I think the Artemis 2 and Artemis 3 schedules, at least for the moment, are still targeting 2025.
Yeah.
I'm sorry, 2024. For Artemis 2, 2026.
Yeah, 2026 for Artemis. But I did read an article this week, Lou, that says that what NASA may do is push the crewed landing back to Artemis 4 and use Artemis 3 for another flyby. That's what I read this week.
Okay, that's news to me.
Yeah, I read that this week. I couldn't quite pin down the source of it, though, so maybe it's true, maybe it isn't.
I'll do some snooping around. I'll find out.
Yeah, if you could, that'd be great. But providing all goes to plan, then we could well have humans living and working on the moon in a permanent base by that time. Talking of the moon, Blue Origin have revealed their new lunar lander called Blue Moon. The new version of Blue Moon, because there was a previous design that was totally different. This is a really strange story, and I'll tell you why. They've revealed the lunar lander, but this is not the lunar lander that NASA has contracted them to build to land people on the moon. This is the cargo version of Blue Moon. And the way that it's worked is that SpaceX are contracted to land people on the moon for Artemis 3 and 4 using the lunar version of their Starship, which is cunningly entitled Lunar Starship. And there's a long story associated with this, but basically Blue Origin eventually got the job of building a moon lander to land people on the moon after Artemis 4. And when they said that they'd unveiled a mock-up of it, I thought, well, that's great. Let's have a look at this. But then it turns out that this is actually the cargo version, which will be or possibly used at some time in the future, especially when there is a lunar base under construction to deliver cargo to the moon's surface. And it seems a little strange that they've unveiled this years ahead of when it will actually be needed. And it's really strange. There's no sign of the design for the lander that they're contracted to land people on the moon in. So this is a little strange. It's intended to launch on a Blue Origin New Glenn rocket with its large 7-meter fairing. Now, New Glenn is Blue Origin's new rocket to put stuff into orbit and to boost it towards the moon. But that hasn't flown yet. It's due to make its maiden flight sometime next year. Blue Origin are very secretive about things, and they haven't announced exactly when. We don't know how much of New Glenn has been built. They haven't shown us any images. We've seen a mock-up of the first stage of New Glenn, and that's about it. So all of this is a bit strange. They've also bizarrely announced a new spacecraft, a new vehicle called Blue Ring, note it as please, which will provide logistics in terms of power and computing, all very ill-defined. And it's worth reminding everybody that Blue Origin have never actually launched anything into space after 24 years of existence. All they have done is to fly tourists up in the New Shepard Joyride spacecraft to the edge of space, but they've never put anything into orbit after 24 years, yet they still keep getting massive contracts. And it's a complete mystery why you would keep giving contracts to a company who've never actually done anything. Now, this is what the Blue Ring is meant to look like. And me being cynical, I reckon, well, it's possible that they've invented this so they can get yet more contracts to build it from NASA, but it doesn't actually exist. And, what is actually going on there? Well, I think personally, NASA are scared stiff of Jeff Bezos, because if you remember, after they failed to get the contract for the human landing system, the lunar lander, which was given to SpaceX, they took NASA to court, and there was quite a lengthy court case. They took the Office of the Inspector General to court, and they lost, basically. And I'm just wondering if NASA are so scared of Bezos suing them, because Bezos is very litigious. He's got his lawyer on speed dial. He sues at the drop of a hat. And I'm just wondering whether they just keep giving him contracts to stop him taking them to court. Because, to announce yet another new spacecraft that they haven't built, that there's no specific design or purpose for, it all seems a bit strange to me. Anyway, perhaps it's just me. Anyway, got a lovely story for you now about the JWST. Now, what is this all about? On the right, we have a galaxy, which is about 1 billion light years away. And top left is a kilonova. What is a kilonova? A kilonova is the collision and merging of two neutron stars. And it causes a massive explosion, one you can't comprehend in terms of the amount of energy released. And this kilonova was two neutron stars colliding and merging that originally came from that galaxy you see towards the bottom right. Now, what astronomers think happened is that due to some interaction, perhaps with the supermassive black hole at the heart of that galaxy, the two neutron stars, I don't know if they were pulsars, but maybe, the two neutron stars got thrown out of that galaxy, and they've gone some considerable distance. So it obviously happened in the distant past. This kilonova, this explosion, was first seen in March, and it was two neutron stars, and they've been orbiting together for thousands, perhaps millions of years, orbiting around each other, and they finally merged, producing this enormous explosion. The interesting thing is that if they did get thrown out of that galaxy, then they must have got thrown out together, still orbiting each other, which is interesting. Why is this important? Well, it's interesting in its own right, of course, but there's something else. And let me just tell you what it is. The question that astronomers have asked for a long time is, where do precious metals, heavy metals like gold and platinum, actually come from? Well, if you know a little bit about the evolution of stars, you might know that any elements heavier than iron are made through nucleosynthesis in supernova explosions. But a couple of decades ago, astronomers began to realize that even the largest supernovae aren't intense enough in terms of pressure and temperature to form elements like gold and platinum. And thanks to a kilonova in 2017, it was a gravitational wave event because it was first observed in gravitational waves, and then right across the electromagnetic spectrum, we found out that the kilonova constructed, I think it was 250 Earth masses of gold and 500 Earth masses of platinum. And astronomers saw these elements forming in front of their very eyes as the explosion decayed. With spectroscopy, they could see all of this gold and platinum being generated. So we had the answer to where at least gold and platinum come from in the universe. They come from neutron star collisions. So if you're wearing any gold jewelry at the moment, or you have got some gold jewelry, next time you look at it, just remember that that was formed probably in the ancient merger of two neutron stars in a titanic explosion called a kilonova. How titanic are these? Well, the one in 2017, in terms of light, was 100 million times brighter than the sun. This is how much energy is involved when two neutron stars collide and merge. Now, having said, gold and platinum are formed in neutron stars, what about other heavy elements? Well, what I'm leading up to is that the Webb has found another one, and it's found tellurium, which is another very heavy element. And the James Webb has analyzed the light from this kilonova and found the presence of tellurium. And tellurium is actually rarer than platinum, but it is another heavy element that we now know is formed in neutron star collisions. So astronomers are really filling in the gaps here, going through the periodic table with these really heavy elements and ticking them off as coming from kilonovae, from the collision of two neutron stars. And it's also found a group of 15 metals heavier than lead called lanthanides or lanthanides. Do you know that word, Lou? Is it lanthanides, lanthanides?
I don't know that word.
No, okay, just wondered.
Nice word.
Yeah, it's a group of 50 metals heavy, and they found those in the light from this kilonova as well. So we are finding out finally where all of these heavy elements actually come from. But I think it's amazing that, the gold you might wear as a ring or a necklace or whatever was created in an ancient collision between two neutron stars. At least that's the idea. So that's quite a really interesting story. And all of these are formed in a process called nucleosynthesis. And basically what happens with nucleosynthesis is that there are massive quantities of neutrons that are absorbed by other atoms, which then form heavy elements. And that's called the R process in nucleosynthesis. And we were saying this week that we might like to feature a thing about the origin of the elements here on Space Oddities. So we might do an item about that in the near future, because the origin of all the elements is really interesting, where they all come from. Okay, moving on to Mars now. Now, you may remember the NASA InSight lander, the late lamented NASA InSight lander, which studied the interior of Mars for 3 years using very sensitive seismographs. There's a picture taken from the lander itself. The InSight lander unfortunately died because dust got the better of it. Dust coated its solar panels eventually and prevented its batteries from charging, and it froze and died. And you can see actually there's the dome-shaped thing in the center there. That's a seismograph. And you can see how much dust has accumulated on it and the cable coming out of it. So we missed the InSight lander, but it has made a really surprising discovery that Mars is surprisingly soft inside. Yes, it's got a nickel-iron core, but that is surrounded by about 150 kilometers of soft, basically molten rock. And this is a big surprise because nobody expected this. And it indicates that Mars had quite a violent, event-filled early history. Instead of the planet forming and then just gradually radiating its heat away into space, there seems to have been quite a lot of interior movement inside Mars that basically has left this sort of molten rock inside it. What those events were, nobody knows, but it is surprising because I think scientists expected to find that the interior of Mars was quite cold, because of its history, what we thought we knew about its history. We knew that Mars froze, the temperature dropped, the atmosphere was lost to the solar wind, and everybody has assumed that it's dead. As we were saying last week, the InSight lander detected the largest earthquake, or Marsquake, should I say, ever on another planet. And it's made an interesting discovery that, in fact, Marsquakes, compared to the Earth in general, are very weak and they don't happen as often. In the past, it's been suggested that people colonizing Mars might be at risk from Marsquakes, but that turns out not to be the case. They're much weaker than earthquakes and not so frequent. So even though InSight is dead, long live InSight, it's still giving us some really interesting data to draw conclusions from. Now, here's an interesting story. US and Australia have cleared legal hurdles for launches. Now, what does this mean? Well, American rocket companies, have not been allowed to launch from Australia because such launches were covered by military regulations, specifically the non-proliferation of nuclear submarines between the two countries, which meant that American rocket companies have not been allowed to launch from Australia. Well, luckily, the Australian government and the US government got together and they've sorted that out, and the rocket launches are now excluded from the military agreements. And what this means is that US rocket companies will now be able to launch from Australia. Americans and Australians will be able to share expertise and technology, and they'll be able to launch from places like the Arnhem Space Centre. Australia has several spaceports. The Arnhem Space Centre is probably the biggest, and this was previously prohibited. So apparently there are already several American rocket companies negotiating with the Australians to set up camp, if you like, in Australia to launch from Australia. The advantage of that is that you can very easily put satellites into polar orbit from Australia. And there are lots of advantages to polar orbits, which we've talked about on this program before. And then lastly, United Launch Alliance are now targeting December for the maiden flight of their Vulcan rocket. We're all waiting for this because it looks quite an impressive rocket, and they are targeting, they are targeting sometime between the 24th and the 26th December. So we could have the first launch of Vulcan on Christmas Day, which would be quite interesting. I hope we don't, because we would like to cover it live, and we may be engaged in other things with our family. But if we can cover it live, we certainly will, because this has been a long time coming. It's 3 years behind schedule. Blue Origin was supplying the engines for it, the infamous BE-4, and they were a long time behind with supplying those engines. They've finally done it. The Centaur upper stage has had some problems, and the whole project is 3 years behind schedule. United Launch Alliance have had lots of military contracts for the Vulcan rocket, and they've all had to be delayed. And at one point, it looked as if ULA were in danger of losing their military contracts because of the ongoing delays. But it looks like it's all steam ahead now. And the first launch of the Vulcan will put a lander on the moon called Peregrine, and this has a UK connection because one of the experiments on Peregrine, and there are quite a few experiments on Peregrine. One of the experiments is a British lunar rover called Asagumo. And it's a very interesting design because it literally walks, or will walk, around the moon on legs. And it's been made by UK-Japanese company Spacebit. And we're looking forward to the launch of the UK's first moon rover, which is very, very exciting. So we hope that this launch is not delayed again, as it's been delayed so many times in the past. But there you are, and there you have the news for this week.
Yeah, and according to I don't know if you saw it, Andy, they've been looking at the Apollo 17 sample returns again for the moon.
Yes,
and they have made the discovery, maybe, that suggests the moon is 4 billion 4.46 billion years old, which makes it 40 million years older than previously thought.
Wow.
So does that mean we've got to move the Gaia hypothesis back? With the collision of the Earth and the proton planet?
Probably. That's probably exactly what it means.
Is that still a feasible?
Oh yes, definitely.
Scenario.
It's definitely the leading explanation that in the infancy of the Earth, it was struck by a Mars-side object called Theia, and the Moon formed from the debris thrown into orbit around the Earth. And in fact, I think the last study showed it formed remarkably quickly within just a few years, because they'd always assumed that if you've got a ring of debris around the Earth that coalesces into the Moon, then it should take a long time. But apparently it didn't. It took an incredibly rapid amount of time for the material to coalesce into the Moon. So that date will have to be pushed back now. And of course, it could be, that geologists and scientists who study the interior of the Earth have found these weird structures towards the center of the Earth that they think may be the remnants of Theia, the planetoid that struck the Earth early in its history, because there doesn't seem to be any other explanation for what they are. So, interesting times. But if the Moon is older than we thought, then yes, the date of the impact with Theia will have to be put back as well, obviously.
Yeah, I think it will take more than a paltry 40 million years to shape the Theia hypothesis. I mean, it works so well for all of these variables that have to fit, such as angular momentum of the Earth-Moon system, angular momentum of Earth, composition of the crust, that kind of thing. So perhaps it occurred a little bit, was it earlier or later? I forget. 40 million years.
It's earlier, so it's older than,
40 million years,
Yes, it's neither here or there. When you're talking about billions of years,
it's a blink. It's a blink. Yeah. Also talking about sample returns, they finally managed to get the lid off of the Osiris Rex sample return. They had 2 bolts that were jammed, and I think all they did is just took a hammer to it, and they managed to actually remove the top of it now, so they've got a good idea of how much sample they're returning. Of course, we already know it's more than what they anticipated, and that was just for the spillage that they had. And also news that just came in while we were actually playing our intro. I don't know if you've seen it, Andy. The FAA have actually wrapped up the investigation now into the Starship investigation fully now. But there is still one hurdle they've got to clear, and of course that's the environmental
wildlife.
The environmental thing before it can actually be issued for a second license for a second attempt. So that's just come into.
I saw another interesting thing relating to that, Daz, today. I think it's the deputy administrator of NASA. She went on a tour of the construction site at Boca Chica, and there's a photo of her in front of a few vacuum Raptor engines, and in the background you can see a Raptor engine because they've all got numbers printed on them. Which indicates, it's a sequential number depending when they were built. And there's an engine behind her with the number 398 on it. In other words, SpaceX have now built nearly 400 Raptor engines.
Wow.
Which is now you might say, well, what the hell do they got 400 engines for? Well, Elon Musk wants to send 50 starships at a time to Mars to build a base on Mars, and for that you need a lot of engines. So SpaceX are building them. They've got nothing else to do at the moment until the Fish and Wildlife Service give them the go ahead for the second orbital launch. So they're spending their time building Raptor engines like hell. But 398. Anyway, she said that she had a fantastic day, and it was amazing to see SpaceX. They also showed her a new Dragon capsule under construction. which she thought was amazing. But reading between the lines of what she was saying, I wouldn't be at all surprised if somebody is putting immense pressure on the Fish and Wildlife Service now to pull their fingers
Back
out
off, yeah.
and not take the 315 days that they have under law to complete their inquiry, which would put the launch of the Starship back till the spring. So watch this, and as soon as we have a definite NASA have actually penciled in. Now let's see if I can remember this. I think it was NASA have penciled in the 11th and 12th of November for the launch. So it's all down to the Fish and Wildlife Service. Now we assume that the FAA will grant SpaceX the license very soon, imminently, maybe within the next couple of days. And then it's just down to the Fish and Wildlife Service to decide whether they are happy with the improvements to the launch site that SpaceX have made with the water deluge system. Did you see that the new full pressure test of the water deluge? It was amazing.
Yes, I did. Yeah, it was amazing.
That was amazing. But if they're satisfied that there won't be another near disaster to the environment like there was on the first launch attempt, then we could see things moving quickly. So.
And you talk about water deluge systems. They also tested the SLS launch tower deluge systems again the other day.
Oh, did they?
So they've tested that again.
Right.
So they're moving ahead with that slowly but surely. Very, very interesting stuff. There's a lot going on in space at the moment. And,
there's a lot going on, and we do try to cover it here on Space Oddities, but honestly, there's such a lot of it in any week. We have to leave some of it out, unfortunately. Okay, let's move on. Now, Daz, you're going to tell us a bit about solar storms, I believe.
Am I? Okay, then.
Oh, okay, if you don't want to.
So I'm just bringing up my presentation.
Okay.
Right, this is basically carrying on from last week when we were talking about the Carrington event. It was a solar storm that hit the Earth on the 1st of September, 1859. Actually, the main part of the storm hit on the 2nd of September, but the whole event started on the 1st, which became known as a Carrington event. And it's become the benchmark of which all solar storms are measured. I take it you can see that, everybody? Yeah. Right, here we go then. So just a quick recap. So 1859, of course, that was Victorian times. The astronomers were limited by what they could use. They did have ground-based telescopes like this refractor, the Leviathan of Portarsdown, which is in Ireland. But there were, like I say, several disadvantages they had. All observations were in visual light, optical light, and it was through the window of our atmosphere. Sun observations were done by projection or through heavily smoked glass plates so they could see the disk of the sun. But they also had no zero knowledge of what the workings of the sun. In fact, some of the people at this time believed that the sun was a big ball of coal that was burning, which was just an extension from in ancient times when they thought it was forest fires on another planet. And they had no idea of space weather. But observing this event was the beginning of the study of space weather. Lost my thing now. My cursor. There it goes. So this gentleman here, he's Christopher Richard Carrington. On the 1st of September, he was observing and he was sketching a sunspot cluster. Also, just down the road from him, there was a chap called Richard Hodgson who was also observing exactly the same sunspot region. While they were watching, they saw a very, very bright flash. And Richard Carrington was observing the sunspots. Oh, what have I done? Gone the wrong way. And this is his drawing. The two maggot features in the middle that you can see there are what they call magnetic arcades. It's the sun repairing the magnetic fields where the flare has actually happened. And it started off in position A and it moved to position B. So this is how the sun was repairing itself. And this caused, although they didn't know at the time, lots of X-rays, lots of radio interference and all that. But of course, they didn't know anything about that sort of thing at the time. At the same time, in Kew Gardens, at the Kew Observatory, a magnetometer, I said it this week, trace actually showed this same event. You can actually see the spike in the bottom trace there. And this actually matched the timing of what Carrington and Hodgson saw. And there is some writing at the bottom where the actual observer of this trace wrote that the times coincided. Right, thank you then. So what happened on the 2nd? They had massive auroras all around the world on the night side of the planet. But what it was more renowned for, and the geomagnetic storm was so big that the auroras stretched down by visual eyesight down to 20 degrees latitude, just above and below the equator on the north and south hemispheres. So it did stretch all the way down. Of course, usually auroras are restricted to the up by the poles. So we had a lot of radiation storm. Now, one of the reasons that this became noteworthy is the telegraph system was just becoming into its own, and this is the sort of equipment they were using. And what happened is the electric current that was induced in the ground, which then induced in current in all the cables, overloaded sort of like the cables. The voltage was so high that they were able to disconnect their batteries, which operated this system, because we didn't have the electric networks that we got now. And they were still able to operate these for 2 or 3 hours, just using the electricity supplied in the cables from the aurora. You can see the ticker tape there. And what happened was while the storm was going on, some of these machines sparked and it set light to the ticker tape. But these were only very small fires, which were easily put out by the operators. But this sort of basically has spawned all these theories and things about that it's the wrath of God if a Carrington event hit us, the wrath of God, death from the sun, and things like that. But that's all for Hollywood, because it's not happened. We've been through several more Carrington type events since then, and we're still here. I mean, we know a certain of events are happening, but we'll talk about that in another presentation. So what creates space weather and solar storms? The sun is a giant fusion reactor that drives space weather. Just excuse me a minute. There we go. It produces electromagnetic radiation from X-rays through to radio waves. It creates the solar wind that carries plasma and magnetic fields. It has eruptions of solar flares producing X-rays, radio bursts, and solar energetic particles, aka radiation storms. Now, it's the solar flares that bring on the radios. You get a blackout. So shortwave radios, radio hams, and all that will find that they can't transmit anything, and that will be the start of the storm. Someone's making a noise. Sorry. So you got the radiation storm. Now these events, these flares, they travel at the speed of light because X-rays and radio, they're light. So they will travel at the speed of light. That will arrive within 8 minutes. And the SEPs, the solar energetic particles, will arrive about an hour later, and that'll be a radiation storm. So this starts the whole thing off. We then get coronal mass ejections, which then carry the main part of the solar storm. Then what these do is they actually throw out tons and tons of solar material called plasma, which is energized, which is gas, which has got electrical and magnetic currents involved in it. So it actually changes its properties, and it throws them out. These events throw out into the intermediate, into the planetary medium. They're also known as I said, solar radiation storms. And then you have coronal holes, which produce very fast winds that enhance the speed of these events out into the interplanetary space. Let's stop moving my cursor. So I've mentioned 4 events there which we need to look at, and these are what will which actually go together to actually make solar storms. Now, first of all, I said solar flares. Now these so you got solar flares, sorry, mass coronal coronal mass ejections, a coronal hole, which is that black spot in the bottom left-hand side on the sun's first surface, and radiation storms. This is a coronagraph image, and you can see all the snow hitting these sensors, and it's basically a blizzard hitting it, and it'll blank it out so you can't actually see it. So let's just give you a little bit more. This is the structure of the sun, and you've got to look at it as an onion. And what you have, you could start at the core, which is where all the fusion's going on, and then you've got these several layers which are coming out as they come up. And the layers we're interested in is the if you can have a look at there, there's a convection zone. If you look towards the top, it's the third one down. Which and the surface of that, which is the photosphere, and then from that there out, that's what the places we can see. Where you got the convection zone, that is where most of the magnetic fields are stretched and twisted, and they cause mayhem basically. And you'll see in a minute what I actually mean. So because as you know, the sun rotates, the actual equator spins faster than it does at the poles, and it actually stretches the magnetic fields. So what have we got? So these are sunspots. Now you'll find these on the surface that we can see, and we can see these in optical light. Now what's happening here, as I said, when you get these all these magnetic fields being stretched, it causes mayhem underneath. And what happens is the magnetic fields become warped, and what will happen is it will form sort of like a bubble shape. They can actually, the main line will break, and it fixes itself with a sort of like a patch over it. This will form a bubble, and the convection that's pushing the plasma, which you can see underneath, because usually you can see it's all like this textured effect on the sun surface. That's the plasma pushing its welling its way up. It will actually push this bubble of magnetic lines up towards the surface. Now, where the actual spots are, the magnetic lines have actually pushed their way through the actual surface of the actual sun. So they're actually, if you can imagine, there's magnetic lines going from one large sunspot to the other sunspot, and one's north polarity, one's south polarity, and it basically forms a big tube with this magnetic lines across the top of them. The reason why the area is dark is where these have come through. There's a lot more that actually is involved in this, but it's where it's pushed through. It prevents the actual plasma from underneath pushing up to the surface, and so basically it's a colder spot, and the surrounding area, all the plasma is pushed up to the top, and it gives you the lovely yellow color. But where it can't break through, you've got the black spots, and the umbra is caused by the magnetic fields. There's a lot goes on here which I won't go into. But so you've got a magnetic field stretching between the two. Now, what can happen is you can see here, you can see some of these magnetic lines. Now, you're not actually viewing the magnetic lines, these loops that you can see. You're not actually viewing the magnetic lines. You're viewing the plasma and the charged particles that are rushing backwards and forwards down them. They're so superheated, and when you look at it in this wavelength, you can actually see some of the actual magnetic lines. But if you look up towards the 2 o'clock position, you'll see a very bright flare with some refraction spikes on it. Now, this is a flare actually happening, and what happens is these magnetic lines, they get tortured and twisted. There is a lot involved in them, but what will happen is they will snap, and they will throw out a load of magnetic into magnetism into space. But also at the same time, it will create X-rays, both hard and soft, and a lot of radio interference, which will cause the blackout when it hits the Earth. Now, these events, as I said, they travel very fast. You'll know within 8 minutes, because it's light that's doing most of the traveling, and the radiation storm will follow on later. But they will travel a lot faster. The next thing, which is a component of a solar storm, is coronal mass ejections. Now, these again are magnetic lines that have joined big spots, but they can also join between magnetic regions where we've got plages and things like that. And these filaments here, these flares, this sort of like dome-shaped thing on the side, is actually plasma traveling along the magnetic lines, and it's just traveling along the lines in between each spot. Now, sometimes these can erupt as well, and these will break away. Now, these will throw out millions of tons of plasma, energetic material out into the space, into the interplanetary space, and it'll move away from the sun itself. Now, this will actually form a sort of like a bow wave. It will travel out into space, and it'll form a bow wave which will spread out slowly, carrying all the plasma with it. There is a lot more detail that's involved with it, and it's all to do with the magnetism and the fact that the plasma is ionized gas, and it can actually see the magnetic fields in this bow wave, and it actually gets trapped in it, and then it'll moves out to either towards or in whatever direction it's got. So you can see the plasma prominence on the left. On the right, you can see a coronagraph image where the sun's been blocked out, which gives us a view of the corona, and you can see these events moving out into the interplanetary.
And if I could just interrupt a second, Daz, of course, these are the most dangerous as far as the Earth goes, because they can release up to 1 billion tons of matter. And if its point is straight at the Earth, that's when we could have real problems.
Yeah. Thanks for that, Andy. So, okay then. So again, here we have, now this is the magnetic storm. Now, solar flares can happen on their own. Coronal mass ejections can happen on their own. Can happen on their own. But sometimes they will happen together, and this is when the events start to get quite serious. If you get a coronal mass ejection where it's throwing out all the material into space, and then you get a flare right behind it, then it will actually force that material even faster out into space. So it gives it some more oomph, and it gives it more energetic particles into the actual bow wave itself. So what you've got here is a coronagraph image, and you can see it's from what does it say? From stereo. And you can see on the left, it's nice and clear. You can see all these streamers. This is the solar wind, the streamers you can see. But when it's been hit by a radiation storm, you can see all this snow. And if it's bad enough, it will actually blanket out for the duration of the actual radiation storm passing by. Coronal holes. Now these, they're not actually a hole in the actual sun itself. You couldn't travel down it. You won't fall down it. But as you can see, there's a lot of events happening on the surface of this sun. Now, what this is you can see all this turmoil is magnetic activity on the sun. Now, the next image, which I'll try and explain what's going on here. Now, you can see right in the center, there's obviously what possibly is two sunspots. You can see all the magnetic fields passing between the two. You can also see off onto the right, there's some more magnetic stuff going on, and to the left. But if you notice, there are areas where it's devoid of very much magnetic activity. Now, where you've got all the activity, the magnetic activity, it's trapping all the plasma, well, most of the plasma inside itself. So that is very, very hot. Where you haven't got very much in the way of magnetic activity, that is enabling the plasma to actually escape out into space, creating these solar winds. And these solar winds from these dark areas, as you can see on the left there, are very, very fast. Now, if they get behind a solar storm that's just happened, an eruption and a flare, they will enhance the solar winds and they will push these events on even faster. Now, as these bow waves pass through the interplanetary space, they will also catch up with any events that have happened before. And they will then sweep these up. They don't, it doesn't slow down the big storm. All it does is it just takes on all the energy that's in this previous storm that it's just caught up with, and it would just carry on at exactly the same pace. So this is the last slide I'm actually going to show today. So what we're looking at is when we've got a quiet sun, and we look at it through coronagraphs and through all our space telescopes, which again can look at the sun in different wavelengths, because these events happen in different layers. And I will talk about this next time, and we'll talk about the types of telescopes we've got in space to enable us to do this. So when we've got a quiet sun, what we'll usually see is the solar wind, which is constantly there. And as I said, this carries energetic particles, SEPs, but also it carries the sun's magnetism, and it takes it out all the way to the edge of our solar system, which forms our heliosphere. And we need this to protect us from gamma rays coming in from outside the solar system, which can be just as lethal as anything that can come from the sun. So what we'll see is we'll see high-speed streamers. Again, like I said, when we saw the coronagraph, you saw the streamers coming out. That is the, in some places, more energetic than other places. Again, because that's probably where corona holes are, and you've got enhanced solar streams coming out. And you'll also see interplanetary shock waves from smaller flares and solar flares, and from coronal mass ejections. We can actually view them penetrate out into the interplanetary space stations, but space stations, interplanetary space. So we can actually view those using coronagraphs. That's what we'll normally see. But when we've got an active sun, we get solar flares, which I said release X-rays and radio bursts and travel at the speed of light. These are the ones that cause us trouble with radio communications, which we've got to be concerned about, because when you've got a lot of NGOs, people who actually respond to disasters and things like that, need to be able to communicate. So if you've got no radio, you can't talk to each other. Then you'll get that'll be followed by a solar storm, which then will be mainly protons and electrons traveling just under the speed of light. So they'll probably arrive about an hour later. So it's already setting up the Earth's magnetic field, and the Earth it's cleared the way for the big storm to come in behind, which is created by the solar mass ejections. But when the coronal mass ejection hits, You've got massive amounts of solar plasma and enhanced magnetic fields. It's called a geomagnetic solar storm. It drives strong shock waves in space. They're slower moving, and when I'm talking about slower, we're talking about 1,500 kilometers per second. It's not, but relative to the speed of light, that is slow. And they normally take between 2 and 5 days to arrive. And as I said, they cause a geomagnetic storms. Now, these are the things that can interfere with satellite communications, satellite mobile phone communications, GPS, and things like that. And again, it's something we need to worry about, because with the GPS and things like that, again, going back to the disaster relief, they will use drones to survey areas. And if the GPS has gone down, then it makes it hard for and plus also with the radio signals that need pass between, it makes it almost impossible to use drones. So this just gives you a bit of an idea of what we need to be concerned about. And as I said, if you want to know anything deeper, just look for Tamitha Skov, that's Skov, the space weather woman, and you'll find that she's got some what she calls mini series, which is a bit optimistic to call them mini series, because they last about 2 or 3 hours, 2, 3, 4 hours long. But what the idea is she produces one a month, and you spend all month watching it. And it is broken up into sections, and in between the sections she takes questions and answer sessions. So if you want to go really deeply into it, then that's the person to see. The next one I will do with these, we will actually talk about what effect the solar storms have on the Earth when they actually arrive, and also how we decide whether or not it is a Carrington type event. So I hope that you understand that, and everything was clear. So thank you very much.
Great, thank you, Daz. That's absolutely wonderful. Very, very interesting presentation. So thank you very much for that, and we look forward to next week. Incidentally, just to give you some idea of the energy involved here, because as you know, I recently wrote an article about the Carrington event for earthsky.org, and the Carrington event released 10 to the power of 25 electron volts. That was the energy involved, which works out, if I remember rightly, to about 10 million hydrogen bombs. That's the amount of energy that was released. So so nasty things are CMAs, and let's hope we never get a full-on one, because, well, we know what the effects might be.
Yeah, I mean, the Carrington event, as I said, is considered the benchmark.
Yeah.
But every event, every sort of like Carrington type event that's happened since, they're all the same. The mechanisms for creating them are the same, but they've all had different characteristics. But we know of the sort of like no spoiler alert here, 1989 with the Quebec blackouts, but there have been others which have had different effects, some of which you probably won't know about because they were classified at the time.
That's right.
We'll talk about that next week.
Okay, thank you for that. We need to say apologies to Peter Larkin. Your gallery image didn't make it into the gallery this week, but don't worry, it will be in next week's. And can we just ask viewers that if they are going to send images in, they get them in by about midday on Sunday, to give our lovely Rachel time at the weekend to compile the gallery, because she's a very busy lady, is our Rachel, because she works and she's looking after a young son and an even younger husband, and she needs time at the weekend to put the gallery together. So could we ask for a deadline of midday on Sunday if you want to send an image in? As I said, you'll always get your image in the gallery, and but it may wait till the next week if it arrives late. So sorry, Peter, that yours didn't make the cut this week, but it will. Also, thank you to those of you who have bought us coffees today. It's very kind of you, and we shall enjoy the fruits of that by keeping the ship afloat. And I think that just about wraps it up for tonight, does it not?
Yeah, well, Steve, I've just a message that Steve's put in, Steve Warbis, our old friend Steve. He said he witnessed a coronal mass ejection event 18 months ago through his solar scope. And of course, to see these events, we've got to look using different wavelengths of light. And this is what I will talk about next time when we talk about the space telescopes and the different wavelengths they look at them. You see different layers of the sun. It's like an onion.
Definitely. Well, we will see you next week. Next week, I will, all being well, be delivering my report from the Mayo Dark Sky Festival in Ireland. And Gerard, yes, I will be imbibing plenty of dark matter in Ireland. You can be assured of that. They tell me that County Mayo in Ireland has the best Guinness in all of Ireland. So I have to, of course, I have to do a consumer survey of that. I have to actually put that claim to the test. Otherwise, it could be construed as misleading. So I'll be reporting from the County Mayo Dark Sky Festival, where I will be giving a lecture on gravitational waves. So if any of you are in County Mayo, and I will be in, I believe my lecture's in the Newport Hotel, if I remember rightly. But anyway, it'll all be in the programme. And there we are. So I would like to say goodnight to you. It's great to have some new faces in the chat tonight, guys. I don't know whether you noticed. We've got Claire. Some apologies if you've been here before, Claire, and I haven't noticed you. But we've got a few new faces in tonight, and you're all very welcome. And we hope that you're going to stick with us because, as you know, if it's happening in space, it's happening here on the Space Oddities, and we do our very best to bring you everything. So from all of us, from Daz, from Roger, from Michael, from our very own Clive Dunn, Lou Mayo, and
Granddad, we
love you.
I don't like enough my granddaughter now.
Sorry, you probably don't know who Clive Dunn is, but you are a dead ringer for him anyway. So there we are. And you go off now because you've got to join the cast of Chitty Chitty Bang Bang at the theatre. So there we are. Lovely to have Rachel back, isn't it? So I think we should give Rachel a round of applause. So
bring some glamour back.
We've missed you, Rachel. So thank you for being here.
What are you saying, Michael?
What's all that? Okay. Oh, yes, Steve. Yeah, you could well be right. Look at that.
That's indeed.
Yeah.
Rabbit.
rabbit.
Sorry, Lou. We're not being unkind to you.
I get to go trick or treating, and you don't.
Yeah,
that's true.
Candy time.
Oh, that's true. Yeah.
Yes. Well, have a great time, Lou. Hope you enjoy the rest of your Halloween.
Yeah.
I know. What was that photo you put on Facebook of that immensely tall figure? Was that outside your house?
Oh, that was Slender Man. Yeah, that's a.
You've got a Slender Man outside. If you haven't seen Lou's photo of his Slender Man. Sorry, that sounds a bit wrong. Sorry, that came out wrong. If you haven't seen a photo of Lou's Slender Man figure outside his house,
other types of man are available.
Yeah. I think you did post it in the Space Oddities group, didn't you, Lou? Or did you not? I don't know.
Not Space Oddities. I did it on my my personal Facebook, so people would have to friend me.
Yeah, but if you search for Lou Mayo, you'll find him on Facebook. And
here we go.
There we are. Because it's stunning, Lou. It's absolutely stunning.
Let's see if we get that in there. I don't know if it'll.
Well done. It's absolutely stunning. Oh, there we are. Oh, can't really see.
It's not very good.
No, not showing.
No, I have to take off my background.
Of course, Mary also did her garden up again. I think it was a zombie roller coaster she did this time.
Oh, yes. Did you see the photos of that? Really, really cool.
Yeah, let's hope she takes it down before the storm hits, because I remember a couple of years ago she had a tornado rip through her garden. If you remember that. Yeah, I didn't know Mary knew so many words. There we are.
This is Lou's Slender Man outside his house. That's amazing.
I used to scare the pants off my daughter. She couldn't get to sleep.
I can imagine. And Claire says she did a wizard, so you're sort of in good company there. Yeah. And thank you for being here, everybody. So anyway, look, there's a nasty storm coming into the UK. Stay safe, everybody. and we will see you next week. Daz will be carrying on with his presentation about the sun, which we are enjoying greatly. So well done, Daz, because I know how much work goes into these things. And thank you for that. We will, of course, be having other stuff, my report from Ireland and some other stuff next week, and all the news, of course. So from all of us here at Space Oddities, look after each other, be good, be safe, take care of each other. And we will see you back here at the same time next week. And enjoy your week, everybody. Thank you so much for being here. And thank you for the coffees. All right, guys, that's it from us. Goodbye.